This is a theorem that I promised you all, and the theorem is the definite integral as the area of a region. So this is just a formal definition of the definite integral. If f is continuous and non-negative, right now we're focusing on non-negative functions. On the closed interval from a to b, remember we do need to make closed interval a to b because we do need to know where we're starting and where we are ending. Remember, we can integrate on a closed interval, we cannot differentiate on a closed interval. Remember, because we need 2 points. This is amazing. Here's where you need to start really making both connections, okay? So then the area of the region bounded by the graph of f of x, the x-axis below, and the vertical lines x equals a and x equals b is given as this right here. The area is equal to the integral from a to b of whatever function it is, the curve that they're giving you, and with respect to what variable. Well, are we going to be dealing with x's? Are we going to be dealing with t's? Remember, when we're talking about velocity, these functions will transfer into that. All right, velocity, we're talking about time, x, k, h, any variable, right? When we're talking about the height of something, we need to differentiate with respect to time, dh, dt, and stuff. Well, here we're differentiating and integrating with respect to the variable x. This is what we have, and this is what it looks like. So let's actually put it into practice. What does it mean for us to have the areas of common geometric figures represented by an integral? Remember, that's what it means. A definite integral is nothing but just a number that represents a certain value, which is the value of the area under the region above the x-axis from a to b. Let's look at example numero A. No, wait, letra A, letter A, the number. What is this saying? This is saying take the integral from 1 to 3 of this function with respect to x. When we were to graph this, what does this function mean? If you were to graph f of x is equal to 4, well, that is nothing but just a constant function, y equals 4. If we're going from what, 1 to 3, from 1, 2, 3, 4, we are going from 1 all the way to 3 under this function above the x-axis, and we get nothing but a rectangle. This rectangle has a height of 1, 2, 3, 4 and a base of 2. 2 times 4 is equal to 8. The value of this definite integral is equal to 8, which is the area under the curve. Now this one, what is this one telling us? Well, is it a geometric figure? It is a geometric figure. What geometric figure? It's a trapezoid. This is a trapezoid. If you were to tilt it, grab this baby like this, and now tilt it, and now you have a nice little trapezoid. Alrighty, what is the formula for trapezoid? Remember, we need to calculate the number, but we can actually go ahead and see what this is in terms of the function. We want to represent this area as a integral here, a definite integral from a to b. Well, we can say the a is from 0, all the way to b equals 3. So from 0 to 3, oh, what function? What is this function that I'm calculating the area under? Well, it seems to be a linear function. Well, if it's a linear function, it needs to be y equals mx plus b. Y-intercept is 2. The slope, if we're at 2, this is 3, 5, which is 1. Hey, so we have x plus 2. What variable are we using? We're using the x variable, right? So it's the x. That's how we just represented this one as an area. And I leave it up to you. Find what is the formula for the area of a trapezoid. We are going to need it. So that's that one. And now we have this one. This is the last example that I have here. And I'm asking you how to remember, this is a basic geometric figure right now. We have not done any integration, and we're going to find that later. By the way, this is just supposed to be a number. You're supposed to give me one number that is going to be a question that I'm going to be asking you. And now here, we want to sketch what this function looks like. Do you recognize this function just by looking at it? I don't think so. All right, well, I don't at least, right? So, but then I know, like, wait, this is a function. Well, that means that y is equal to square root of 4 minus x squared. What happens if I square both sides? Well, I have x squared is equal to 4 minus x squared. What happens if I move this to the other side? I have x squared plus y squared is equal to 4. Do you recognize this function now? Manipulation of functions. You need to be able to manipulate your functions algebraically. There is no calculus here at all. This is just algebra. Geometry and algebra. You see, the calculus was, do you understand that the area under the function is an integral? Yeah, okay, calculus is done. The rest is algebra. Okay, so what is this function? X squared plus y squared is the equation of a circle centered at, x minus h squared plus y minus k squared is equal to r squared. The radius is 4, center at no number, so must be at the origin. Center at the origin with radius 2, 1, 2, 1, 2, 1, 2, and then we have this nice semicircle. Semi or semi-circle? No idea. But what is the area of this semicircle? Well, the radius is 2. R is equal to 2. Can you calculate the area? Pi r squared is equal to 2 squared for pi. That is the area. This region is 4 pi. Ta-da. Can we do this? Yes, we can. No, it's not. Why? Because it's not a full circle. It's only half. So this 4 pi needs to be divided into 2. So it's 2 pi units squared. Right? So that's what it is. Be careful with this one. Be very careful. Alrighty, so, and I think that is all. There's more videos now where we no longer talk about geometric figures, but actually just start. Remember, definite indefinite integral means I give you a little function with respect to x, and you get a capital F of x plus c. And now definite integral, I give you from where to where, f of x dx. This gives me a number, which is the area. That's the main concept from now. We're going to be focusing on this one now. All right, more algebra. Thank you for watching, and like and subscribe. I'm really liking the growth that this account is having. It's still linear, but okay. But thank you. Have a good day.